Welcome to this short video on inequality. Specifically, we're going to be thinking about visualizing and quantitatively describing inequality. And as a disclaimer to start with, there's a lot of ways you could think about visualizing inequality. There's a lot of different measures for inequality. So we're just looking at one way to visualize it by plotting a Lorenz curve, and one way to measure it, what's called the Gini coefficient, which is closely related to the Lorenz curve graph. So if you're interested in this topic, go ahead and look online, all sorts of measures for measuring inequality. So before we can really measure or plot anything, we need to have some data collected. So we've gathered the data. I put it in this table here. We have 5 quantiles, so the bottom 20% of the population in terms of income, then the second lowest, the middle 20%, the fourth 20%, and the top 20%. And I've listed their shares of income. So the bottom 20% have 1% of the total income. That seems kind of low for 20% of the people to just have 1% of the income. But remember, by definition, this is the bottom 20%. So it's not actually too shocking or too unrealistic for the bottom 20% to just have in the low single digits as a share of income. I picked nice round numbers for this exercise, but for the US, I think the number is somewhere around 3 or 4% for the bottom 20%. Then we can see that the second 20% has 4%, 10% for the middle third, 25% for that sort of upper middle class, and the top 20% has more than half of the income. That's actually not too unusual. In the US, they have the top 20% earns about half the total income. So we could just plot these income shares and kind of compare them, but that doesn't give us much more information than what we can kind of see just by looking at the numbers. We can see that they're increasing. They have to be increasing. Clearly, the richer people will have bigger income shares. So what we're going to do is calculate cumulative income shares. So the CUM here is short for cumulative. And basically, we do that by just adding up the income share for the current quintile and any quintiles below that. So for the bottom quintile, there's no quintiles below it, so their cumulative income share is just 1%. For the second quintile, we add the bottom 2 quintiles, the second and the one below it, to get 5%. Then for the third, we can add that next 10%, so we're up to 15 as a cumulative share. Then we're up to 40%. And when you add up all the quintiles, obviously you're going to have all of the income accounted for, so your cumulative income share should be 100%. If you don't get that, then we have a problem. And now what we're going to do is take this data, the cumulative income share, right here, and plot it, where we basically say, let's plot the percentage of the population against the cumulative income share. This table gives us 5 points. If we had more data, so that instead of, say, quantiles, 5 groups of 20% of the population, we had deciles, like 10 groups of 10% of the population, or percentiles, 100 numbers each representing 1% of the population, then we could plot a lot more points and get a much more accurate curve. But it turns out we can get a pretty good sense of what the income distribution looks like just by plotting 5 points. So we'll go ahead and plot these cumulative income shares. 0% of the population has 0% of the income, so your first point will always be here at the origin in the bottom left. Then 20% of the people have 1% of the income, so that's tiny dot down here. 40% have 5% of the income, so that's still pretty low, just 5% of the total. Then 60% of the people have 15, 80% have 40, so now we're up close to half. Implicitly, I'm thinking of like the top here as being the full 100% of income. And then when we have all 100% of the people, that matches up with, obviously accounts for 100% of the income, so that would be our last point. And then we can connect the dots to kind of smooth in this curve. And this curve is what we call a Lorenz curve. And what you'll notice is that it curves up. It has an increasing slope, basically by necessity, because as we move towards higher and higher quantiles, those are going to have bigger and bigger shares of income, meaning that at first the curve's going to be pretty flat because the bottom few quintiles don't have much income, so you're not adding much to the cumulative income share. But as you get further and further up the chain, you add bigger and bigger shares, thus steepening the slope. And in practice, what we like to do with the Lorenz curve is compare it to a situation of perfect equality. So if there was perfect equality, the first 20% would have 20% of the income, then 40% would have 40, 60 would have 60, 80 would have 80, and we'd get a nice perfectly straight line representing perfect equality in that case. And the Lorenz curve now lets us visualize exactly how far we are from perfect equality. Specifically, all that gap between the two that I'm going to label as A represents like deviations from perfect equality, whereas what I could call here this area B would be, I guess, deviation from perfect inequality. Perfect inequality would be like as far as you could get from the diagonal. It would be just like a super flat curve that becomes super steep at the end. So A, the bigger A gets compared to B, the more unequal we are. And that's since that's a natural measure, people decided to give that a name, and they call it Gini Coefficient. Coef. And specifically, it's you find the area of A, and then calculate that as a fraction of A and B together. So the Gini coefficient's always between 0 and 1. If A is all the area, it would be 1. That would be perfect inequality. If A doesn't exist because you're exactly on that diagonal, then your Gini coefficient would be 0, although that would be obviously not. No actual society is like that, perfectly equal. But theoretically, you could have a society like that and it would have a Gini coefficient of 0. So higher Gini coefficients, more inequality. The measure is always between 0 and 1, and it gives you a nice one-number summary. If you have to simplify things down to one number because for some reason that's all people are going to listen to, the Gini coefficient's one good number for summarizing inequality. But if you have more time and want more than just one number, our Lorenz curve, which we plotted, and it wasn't too difficult to plot, lets us visualize a lot about inequality, a lot more than just like a single number could tell us. Right, a picture's worth like 1,000 words and 1,000 numbers. So you'll be expected on tests to be able to interpret graphs with Lorenz curves, plot Lorenz curves, calculate Gini coefficient if given the areas of A and B, and in general interpret Gini coefficients like if given some numbers, which countries are more equal, which countries are less equal, and so on. So that's our summary of inequality.